This is exactly how I feel when someone asks me to do a production release. Who of you guys feels just like that when you need to release to production? Yeah. Great, I knew that. And you know, don't get me wrong, I've been working in IT maybe for more than 20 years. I've been working with Liferay for longer than what I would care to admit in public. At Firelay, we have a lot of really well-defined procedures of how to release to production, how to do any of our deployments. But still, there's always one problem. There's always one thing that we didn't thought of that can go wrong. And that's how things work in IT. And you know, I don't know if life is indeed a simulation, as Brian said in his keynote. I don't know if we are really modular and built of all those tiny things and stuff. I don't know that. What I do know is that life, it's about perceptions and feelings. And what you see in this picture is more the way that I would like to feel every time, anytime. At peace, really among friends, having a warm sensation. And at Firelay, that's exactly what we try to do. We try to give our customers peace of mind, and we want to let them know that if they are going to release to production, everything will go fine. At Firelay, for those who do not know, we are the only European Liferay hosting partner, and we are ISO certified, which should give you a lot of trust. But still, we are all humans, and humans are unpredictable. Even if we do our best every time, some things can go just wrong. So we need to get predictability. And what I'm going to tell you right now is the story about how we have been working to move all our infrastructure from virtual machines and how we managed everything to get to a fully Dockerized environment, which is not completely 100% in production yet, but we are very close to deliver that. So the first step that we took was 6 years ago. I was not at Firelay at that time. I just joined Firelay this summer officially. I've been working with Firelay together for the past 4 years, but officially 6 months ago, more or less. So the first step was to introduce Puppet. So we had Puppet as our configuration management tool, and that made things very predictable. We were able to configure any of our application servers, any of our proxy servers, whatever, with the certainty that things were just going to work, that they were going to be configured in the way they should. And with Puppet, we had 2 different experiences. First, we used a version with a Puppet master, and the Puppet master was in charge of all of our infrastructure. It was in charge of configuring everything. But that had a couple of disadvantages. The Puppet master started to have a lot of performance issues, managing too many nodes, and it started to be slow, and we struggled with that. And the second thing was that sometimes we had changes that were kind of unpredicted. Something I really loved about that, I just started to work with Firelay at that time, and they told me, if it's not in Puppet, it does not exist. Everything was configured in Puppet, so it was really reliable. The problem was that Puppet was running every 15 minutes, and sometimes some changes propagated to the servers without being exactly what we expected on those servers. Then we moved to the masterless Puppet. Here, we tried to manage it in a way similar to what Ansible does. Thank you. To what Ansible does. And what we did in this case was that we had a configuration specific for each server, but it was versioned and it was local to every server, and it ran only when we wanted it to run. It was very good. It allowed us to upgrade to newer versions of Puppet in an easier way, and that was very good, but it also became really hard to manage. But at least we had predictability. a lot. But recently we said configuration management is not enough. We need more. We need more agility. We need to deliver better environments to our customers and to developers. And let me explain you a little bit what's the problem here. Imagine this is a typical scenario that we have. A test environment, an accept environment, and production environment. Here I'm omitting the development environment, but every developer has something kind of similar to the test environment, even simpler normally. But imagine, just ignore the rabbit for the moment, and let's just assume that Nginx is there and everything works fine. Developers are working on their workstation, and it's very likely that they will not have Nginx there. There will only be Liferay, and if they need MySQL or Mongo in this case, it's there. They deploy something to test, and it's very similar. Something might come up with their Nginx, but it's very unlikely. If they move to accept, maybe in accept we have a cluster, and the developer is not able to test against that cluster. So things can come up. And when it goes to production, it gets even more unpredictable. Because, for example, you can have a Mongo replica set, and the developer will not have that in his computer. So in this scenario, you're kind of delivering untested software to production because you were not able to test all the scenarios there. Then imagine a little bit from a DevOps point of view. The rabbit here is Varnish, a caching system. I don't know if you're familiar with it, but we're configuring Varnish here. OK, but Varnish is here, and Varnish will catch, and it's configured to use one Liferay. But when we go to accept, it's a Liferay cluster, so Varnish should be doing the load balancing also. In test, we were not able to test load balancing because it's only one Liferay node. Of course, we can fake it. We can add an additional connector to Tomcat and kind of fake it, but it's still not the same. And when we go to production, it's even different. Now, if you wanted to have the same production environment in accept and test, that will be very expensive because you have to pay for all the virtual machines or hardware or whatever you have there. So there is where we said we need something more agile. We need something that really allows you to provision environments only when you need them and destroy them the moment they are no longer needed. And unless you have been living under a rock for the last 2 years, you have to be familiar with Docker. And well, Rocket also maybe, but with Docker in this case, which is what we chose. According to RightScale, they conducted a survey, and the top 3 tools for DevOps today are Chef, Puppet, and Docker, with Chef having 32% of the market, as well as Puppet. They are kind of the same. And the third most used tool is Docker. They are not exactly the same. The first 2 ones are configuration management tools. Docker is containerization. But what's amazing about Docker is how it has been growing. Last year, it had only 13% of the market. Now it's 27%. And this same survey said that 21% of organizations that are using Docker also in production, not only in development. But getting there has a lot of challenges. So if you don't want your Docker project to end just like that, there's a lot of things that you need to consider before moving to production. So the first challenge that we encountered was storage. As you might know, containers are created and destroyed, and everything that you write inside those containers will be lost unless you provide a different mechanism to keep that information. So for that, Docker provides you 2 alternatives, using volumes or volume containers. Volume containers are kind of containers that are only used to maintain data. It will also persist to a mounted volume as the volumes that are directly mounted, but you have to make some choice of how you want to handle that. We chose for using directly volumes. We didn't saw big advantage in using the volume containers. You will see why in a moment. And also, you need to know how to back up all that data, and that also influenced our decision. To do this, we evaluated many technologies. If you know Ceph at the object store and Gloucester, for Ceph you need to use Ceph FS on top of that to be really able to use it as a file system. You have also Gloucester, both distributed file systems with nice projects that allow you to containerize them, and it's a very nice distributed file system. And we also evaluated OpenCFS, which is the option we decided for, and mainly for two reasons. One, it's older, more stable, and it allows us to create snapshots in a matter of milliseconds, and it also allows us to create differential snapshots. And what does this mean? That you can create a snapshot that only includes the changes that occurred since the last snapshot that you took, and that is very fast and very fast to restore also. And you'll see why that is important. But this is the first challenge that we needed to overcome. Then, security. Docker is a very young technology, and it has been evolving and evolving and evolving and introducing breaking changes and more breaking changes. So you really need to work hard to be up to date. And yeah, it's really challenging to be there. And the recommendations we can give you regarding security is the first one: create your own images. Do not rely on the images that are published on Docker Hub. There are some ones very, very nice, but for example, if you look for Liferay images, you will find a lot of Liferay images where Liferay is running with as the root user. So that's not what you want in your production environments. And that's my next point here. The security best practices that you use when you set up an environment in a virtual machine or in a real machine, those same considerations need to be taken here. And the other security consideration that we have is use a secret vault. You need to include passwords for your databases, passwords for a lot of things. Use a secret vault who should be in charge of delivering these information, these secrets to your applications. We'll move to the next challenge that we have, which is logging. Once again, containers are created and destroyed, and all the logs that are generated will go away when the container is destroyed. So you need to store your logs somewhere else. And Docker provides you many log drivers. The one we selected is Gelf, which is the driver for Graylog. And that was really cool. We already use Graylog for other projects that we have, so it was very easy to send all the container logs to Graylog. One thing that you need to be very careful here is to choose the naming for your containers, and what you are sending to the logs needs to be something that allows you to identify the container or the application that was running there, even if the container is recreated again. But that's only a configuration thing. Then we have monitoring. When you have your infrastructure and you're working with real servers, well, you have a limited set of things to monitor. When you start using virtual machines, this multiplies by a lot. But when you start using containers, this really becomes exponential. And also, normally, one of the ideas when you're using containers is that you have to monitor in a proactive way so that you can respond to changes in load and eventually do dynamic provisioning of new environments. In the case of Liferay, we didn't even consider that because the first thing is licenses, because we're not really able to give you licenses dynamically. Liferay can, I learned that this week, so maybe that's something that we could consider for the future. But the first thing was that. But anyway, you start monitoring, and the number of metrics that you will receive will grow exponentially. Normally, we were using Nagios for our monitoring, but it's absolutely not a right tool to monitor containers. So we started evaluating, and the first option was Riemann. It's a tool special to monitor distributed systems, absolutely amazing, with one small or big disadvantage. The configuration files are Clojure. So you have to learn Clojure to configure Riemann. So I said, OK, I haven't had time yet to learn OSGI. And I have to learn Clojure just to configure Riemann? No, this is not the tool for us. So what did we do? We used a combination of cAdvisor and Prometheus. cAdvisor is a tool from open source by Google. And what you do with a cAdvisor is that you install it in a host, and it will detect all the containers, the Docker containers that are running. It's not Docker specific now that I remember, but it will detect all the containers and will start retrieving metrics from your containers every second. So that's one of the reasons why Nagios is not well suited for this. And it will start forwarding the metrics to Prometheus. And Prometheus is a very nice monitoring tool, open sourced by SoundCloud some years ago. And it's very nice with an alerting system, graphing system. It stores everything in Elasticsearch. So it's, well, kind of the same tooling that we are used to use for our infrastructure. So that was very good. Our sixth challenge was how to deploy our applications to a Dockerized environment. And what we did here is that we have many steps when we perform a deployment. I will not say when we deploy, because that's already taken and used as a different brand. But what we do is that the first thing is taking a CFS snapshot, and like that we have the full status of your application before we are deploying a new plugin. And then what we do is that based on the configuration that we have for you, that's something we keep in Git, a deployable, which can be any of your plugins, and a base image, we create a new image that then allows us to create a new container with the application. And what's the advantage of doing it like this is that we can have your application running, and until the new container is not created, we will not start redirecting traffic to the new application that we deployed. OK. Then we have more challenges, updates and upgrades. I don't know if any of you heard about the Docker blackout from June. No, but yeah, you're familiar with that. Yeah. If someone suffered for that, it was very simple. The guys from Docker pushed a corrupted image to a repository, and everybody who updated that day had no Docker for like 10 hours or so. So that could have been avoided. Use a private repository. We do that both for our operating system and stuff, and also for the Docker registry. We use Nexus for the Docker registry. And pin and hold versions. Don't allow versions to just get updated automatically. That can give you very big trouble. And something that's very important, and there will be no containerization talk without mentioning pets versus cattle. All your containers should be treated like cattle. You should be able to rebuild them without any problem at any moment. But you still need pets, and we do have pets. For us, there are two very important pets, and one is our file system. CFS is very important. We need to really take care of that. And the other one is Docker. We invest a lot of time in Docker, keeping up to date with everything that happens there. And what's next? Orchestration. The main thing with containers is that, well, they need to be created, and if something goes wrong, it has to be moved to a different host, and you should not suffer for any of those problems. So our first approach was to use Docker Swarm. We were very lucky because we started working with Swarm with a version that was already stable. If we had to do this maybe 1 year ago, it would have been a continuous nightmare. But right now, Swarm works decently enough. At some point, we said, Kubernetes is there. I went to a Kubernetes talk recently, and I fell in love with Kubernetes. I said, wow, this is awesome. And as my colleague Freirk says, I'm a technology addict, and I want to try everything I see. And Kubernetes is really cool, but it has a downside, and it's that the configuration files use a different format than what you have in Docker Swarm. The compose files, for those familiar with Docker, the compose files cannot be used by Kubernetes. So our choice kept on being Swarm, because this way we can really distribute to any developer a compose file, and he can reproduce exactly the production environment that he will be using. And this allows to test better than if you had a different environment. But we are still doing very interesting research, and we are seriously evaluating Triton as our platform. And why? It has many advantages. One is fully compatible with Swarm. It can just receive the Docker Compose files, and it will just work fine. And it has another advantage. It's built on top of Illuma. And you will say, what the hell is Illuma? Illuma is what resulted of Open Solaris after Sun Microsystems buying Sun and killing Open Solaris. And the guys from Triton reused that and created, Triton as a platform. And you might say, OK, what's cool about that? And the cool thing about that is that the guys from Sun Microsystems were doing Solaris zones since the year 2000, 2001. And the Solaris zones happen to be basically containers. But they have a lot of security issues already solved. They have a lot of things that are already solved. And as we said previously, our choice was CFS. And it happens that CFS is also a creation of Sun Microsystems, and it's native in the Triton platform, so it has a lot of advantages. We haven't done enough research yet with Triton, but we think it's a very good candidate to run our infrastructure. And here, to summarize this is how it looks. We have Swarm, and Swarm is orchestrating all of our containers. We have Open CFS as the file system that is mounted in all of the containers. We monitor using CAdvisor and Prometheus, and we have also Graylog to centralize our logs. It's not here, but Nexus is our image repository. And also missing here is Jenkins, because, this was a talk about continuous delivery with Docker, right? So you will say, what about continuous delivery? So here, I'll stop 1 second, and I'll ask you, how many of you have fully automated tests for your Liferay projects? Can you raise your hands? OK. How many were you? 3, 4? Good. How many of you can say that at least 70% of the functionality of your applications is fully tested in an automated way? OK. 1. Great. So what I would say is that most of you are not even doing continuous integration. So why should we be speaking about continuous delivery when you are not even doing continuous integration? And it's not nothing bad, it's just what is. So continuous delivery goes beyond that. And yeah, we can also go to continuous deployment and push on every commit. But fortunately, this time, before getting to the point where we had built a full platform to do continuous delivery, and we even said, oh no, Jenkins is outdated, that's not modern enough, we should use Go CD, or we should use Concourse, whatever, those are awesome platforms, but the truth is that nobody was using that. And then we said, please, stop building what doesn't work. And what we said is, okay, what those people really want, and it's what we have been focusing on creating. We have been focusing on creating the release button, give you the ability to just say release and go to production. And if something goes wrong, go back to what you had in a matter of minutes, not hours or not whatever. Just like this, be able to roll back. And to do that, what we have created is a tool that internally right now is called the Swarm Keeper. It's a combination of an API and a command line tool that allows you to create projects, create environments for your projects, store the configuration, define in which way you want to configure, because it's, well, in Liferay you have a lot of files, your portal X properties, lots of things that need to be configured. You need to configure your proxies to redirect to the right place. So that's what our tool allows you to do. And that's a little bit it. It's, what we wanted to do is give you the freedom, give you the confidence to jump and be able to say, okay, I made a mistake, and there will be a safety net down there that will catch you and that will allow you to go back to what you had previously. And that's a little bit it. So thank you very much. And if you have any questions, please shoot.
Can you hear me? Yeah. Okay. I have a question about Docker Swarm. You said Docker Swarm, not Docker Swarm mode.
Yes.
Yeah. Can you say something about Docker Swarm mode? Did you investigate it?
What exactly do you want to know about Docker Swarm mode?
Yeah, you are not using Docker Swarm mode. It's much better. It's built-in.
It's built in Docker, yeah. Since version 1.12. It's built in, yeah. And it works just fine. What you have is that you have a
Docker service.
Yeah, Docker service, and you have many hosts managed by the Swarm, and when you deploy, well, you deploy your compose file, and Swarm will decide where it has to be. You define the number of containers that there has to be at any time for any type of...
Is it option for your company?
We are using Swarm mode.
But not Swarm mode?
Yes, Swarm mode.
That's Docker service?
Yes, we're using Swarm mode.
Oh,
yes.
Very nice. Okay.
Yes, yes.
So next question about the logs. What do you think about Amazon logs?
I think
AWS?
I think it's great. We used our decision to go with Logstash was basically because we were already using that, and there was support for that with Docker. So we said one thing less that we have to learn.
Okay.
Yep.
I'm personally using AWS logs, and I have alerts. I have a dashboard with my logs, charts, and so on.
That's something we get with Prometheus. With Prometheus, you can configure the alerts, and you have the dashboards and all of that.
Okay. And the last question.
Go ahead.
Sorry. About ZFS. Can you say something about the performance, read-write performance? As example, I have MySQL database, and can I mount a ZFS to it?
That's the way we are doing it, and so far we are not experiencing any performance issues. There's nothing that we can perceive so far.
Okay, I guess it depends on the network infrastructure.
I think the network infrastructure is by far more important than CFS in this case.
Okay, thank you very much.
You're welcome.
One question regarding the Docker images. You told, okay, you're building images way often, right? If there's no new deployment and so on. Where do you store these images? Are they all in the Nexus or?
Not all of them, and that's why we build the image, because what we do is that we keep track of all the configuration at any moment. So you have, for example, all the files that are configured, we create them, we have something that we call configuration slots, and we define, okay, this is part of the configuration of this server, this is part of the configuration of this server. And then with that configuration, with the plugins that you want to deploy and the base image, we're able to create a new image very quickly and create the container from that image. But yeah, I think that if we try to keep all the images forever, it will continue just growing, and it's easier just to be able to recreate them.
So you have also tooling for that, or is that?
Yes, and that's part of what we developed internally as our tool to manage this.
Oh, this is Zookeeper then.
Sorry?
This not Zookeeper.
Yeah, the Swamp Keeper.
Swamp Keeper. Yeah.
Yes. Not yet, or I don't know if it will ever be. I don't know. Yes.
Any other questions? All right. Thanks, everyone. Thank you, Juan.
Thank you.